We are given that a particle P is moving in a straight line at time t seconds. It has velocity v, where v is given by this. So now the first thing that jumps out at me is that this is a variable acceleration question, because we don't just have v is equal to something times t, like a linear function in v, which gives a constant acceleration. We actually have it's going to be a quadratic in v, which is going to mean that a is also a function of t. Yeah, let's have a look at this. So I'm going to expand the bracket first of all. V is going to be 6t minus 2t squared plus 3 minus t. I've just expanded the double bracket. Then I'm going to write it as minus 2t squared plus 5t plus 3. I want to find the deceleration. So the acceleration is the first derivative of the velocity with respect to time. It's going to be minus 4t plus 5. And it's when t is equal to 4. So a is going to be minus 16 plus 5, which is minus 11. Now we're actually asked for the deceleration. So the deceleration is 11, because it's how much it's slowing down. So it's 11 meters per second squared. And it is expected that you give it as a positive quantity. Next up, we're asked to state the positive value of t for which p is instantaneously at rest. So p is at rest when v is equal to 0, so when the velocity is 0. Actually, typically, you solve a quadratic and you try and factorize it, but we're already given it factorized, so it's going to be 2t plus 1 times 3 minus t equal to 0. And we're asked for the positive value of t. Well, I'm going to get t is equal to minus a half, so I'm going to reject that one. Or t is equal to 3. That's going to be my answer. Finally, we're asked to find the total distance that p travels between times t equals 0 and t is equal to 4. And I think we're being given some hints from part A. So we can see actually that the system is decelerating, so it's slowing down. And maybe at some point the velocity will become 0. Let's take a look. So I would personally recommend, you don't have to, but I would recommend drawing a little sketch of what is going on. And this function I'm sketching, I should say, is v against t. Okay, because the total distance is going to be related to the area under my velocity time graph. Yeah, I can't, suvat is not in the equation here. Suvat, s equals ut, and all that only works when you've got a constant acceleration. Here, we're going to need to integrate our velocity. But to figure out how exactly to integrate it, let's get a sketch down. So what I can see is that I have, okay, I'm just going to write it out again. Now it's a quadratic and it's an unhappy quadratic. A sad quadratic, so I get minus 2t squared. And when t is 0, it's going to go through 3. So the velocity is 3 at time equals 0. We saw then that it's decelerating, and you can also see it from the quadratic, the fact that it's one of these quadratics, it's going to be going down. I mean, it might go up to start with. We don't know, do we? We can't just assume it's going to go straight down. Yeah, I think it's going to speed up and then decrease. Yeah, we can see actually when t is 1, the acceleration will be positive. So we're going to get some sort of maximum velocity. But then actually, remember we found out that it was at rest when t is equal to 3. And then it's going to go down from there. So if I want to find the distance, I need to find this area here. And then is between 0 and 4, so I also need to find this area. But this is why a graph is useful, because you can't just integrate from 0 to 4, because we have a positive displacement and a negative displacement. But we're not being asked for the displacement, we're being asked for the distance. So this bit here is going to be the integral of minus 2t squared plus 5t. Actually, is that what it is? I've forgotten. Yeah, plus 3. Put that in a bracket between 0 and 3. Okay, let's calculate this one. So I'm going to integrate it. I'm going to raise the power by 1 and divide by the new power. So minus 2/3 t cubed plus 5 over 2t squared plus 3t evaluated between 3 and 0. When I put 0 in, I'm not going to get anything, so I don't really need to worry about that. So let's just focus on the other one. Minus 2/3 times 3 cubed plus 5 over 2 times 3 squared plus 3 times 3, which gives 27 over 2. I'll leave it as a fraction for the time being. I might even write minus 0. It's not a bad idea if you got time to just check that using, I would expect to see this level of working, even, to be honest, even in mechanics, just to show that we can integrate it. Having said that, when I looked at the mark scheme, it doesn't expect it. Okay, it will absolutely accept just putting the numbers in. So 0, sorry, that box and the 0 look very similar. Okay, you can literally do this. Now you have to replace all the t's by x's because that's how this function works. I feel like I should put brackets around it. It doesn't actually matter, but I just feel it's wrong if we don't. And we get 27 over 2. So you actually don't need to write that line down. I don't know. I feel from pure mathematics, I just feel like you should. But I'm not too worried about using the calculator from then on. Right, now we've also got this one to find, and it's going to be the integral from 3 to 4 of the same function. So I'm just going to call it v, to be honest. And all right, I'm just going to stick it in now. I feel like I've shown the person marking it that I can integrate. And at the end of the day, we've been tested on the mechanics here, our understanding of. Sorry, I'm having a bit of trouble. Okay, there we go. Good. So minus 25 over 6. And then I need to make that positive. So the distance is going to equal this 27 over 2, that positive area. And then I'm going to add on the 25 over 6. By the way, you could have written this as a single integral as this minus this, because then you get a double negative. So you can you can do that. So 27 over 2 plus 25 over 6, 53 over 3, or 17 and 2/3. Going to give my final answer to 3 sig figs, so it's going to be 17.6 recurring or 17.7. And I think we're working in terms of meters, yes. So there we have it, variable acceleration question, which has involved some differentiation, some integration, some solving of quadratics. Okay, I showed my work in. I think it's good to do that. You do get away with it a little bit. I do think a sketch is useful. Okay, just get into the habit of drawing sketches and seeing it. But you might have been able to see without the sketch that because it goes to rest, the question kind of did help us out. If it goes, it's at rest at 3, then you're going to need to go from 0 to 3 and then 3 to 4. That's the key bit of this question. It might be easy to not realize. Okay, well done.